Section 1.1, Chemistry, Part of Everything You Do. The textbook talks about Taxol. Taxol I first learned about myself in the early 90s. There were several research groups working towards the total synthesis of Taxol. Taxol is a synthetically challenging target, and it's a complex enough of a structure that I'm not even going to attempt to draw it. But the textbook talks about Taxol, and let's put a little bit of information up here about Taxol. Okay, it was found in 1971, and you're going to have to be a little patient. I'm still learning how to write on this tablet, and it's isolated. Wow, this is really bad handwriting. And apparently if I put my fingers on it, that also creates problems. I can't judge distance that way. And I talk to myself a lot, so get used to it. From the Pacific yew tree. Okay, there's no possible way that the Pacific yew tree would have been able to produce enough Taxol for the use that it eventually underwent. It was approved in 2005 by the FDA, so it was approved in 2005 by the FDA for breast cancer treatment. Okay, this is the form of breast cancer that was untreatable or had failed prior attempts. So we're looking at breast cancers that the other treatments just did not work for them at all. So it was approved in 2005 for breast cancer for patients who treatments had failed. So how can chemistry be of use to this? Okay, we know that the Pacific yew tree, there's not enough yew trees in the Pacific coast, the west coast of the United States, to produce the Taxol that's needed for this drug development. And so chemistry was actually employed to come up with a synthetic synthesis for Taxol to be used for this purpose. Okay, I would suggest you look through the textbook under the Taxol and get a feeling for what chemistry has done as far as the development of this particular cancer drug goes. We're going to continue talking about the impact of chemistry on other fields with future slides. So if we continue to use Taxol as our example for the definition of chemistry, let's take a look at this slide. What do we mean by composition? What is it made of? Well, this would be the chemical composition. The structure would be the three-dimensional structure of the compound. Properties would be analysis of these compounds, and then reactions would be how it reacts with other compounds. So in the case of Taxol, leaves had been collected, bark had been collected. They actually extracted the organic compounds from this, isolated those compounds, ran them through a series of tests, finding the compounds that showed tumor resistance behavior, and then using those compounds, they started looking at them more closely, using chemistry and analytical techniques to figure out what sort of elements made up the compound and what the chemicals or the three-dimensional structure of it is. They ask us here, how would we define chemistry? Well, chemistry, to me, I consider, is a central science, okay? So I look at chemistry as a central science, okay? That means that all of the other sciences are tied into chemistry itself. A Physicists would probably argue that physics is a central science, and I would give them a serious thought about that because physics is a very important aspect, but chemistry seems to be at the heart of every one of our physical sciences. If we look at this slide, we can see chemistry located right here in the center. Biology and medicine located right here. This would be where the Taxol example played into. Agricultural, environmental sciences. Without chemistry, we wouldn't have the pesticides and fertilizers that we have today. Our Midwest would not be able to produce the crops in the yields that they produce now, where they've doubled or tripled from the 40s. I'm not sure exactly on those numbers, and take a look at those. Physics and engineering, once again, chemistry is central to that. For those of you who are interested in engineering track, you're actually going to take a chemistry of engineering materials, which is a very interesting course. I've seen the lecture notes for it, and the engineer that teaches the course up there does an outstanding job. Materials. There isn't probably any materials around you that don't have some sort of chemistry involved into them, whether it's the pencil or pen that you're writing with, the laptop that you're looking on, the screen that you're watching, the chair that you're sitting on, and then finally the interactions between chemistry and geology. So when we look at chemistry, we can see that it is a central science to everything around us.